Welcome back to another episode of FRC Robotics 101. I'm Tang, and as we're moving on to the technical stuff of this series, we're going to start with CAD. So, CAD basically is the job of making a 3D model or 2D sketch of whatever mechanism that you're trying to build. This will help your team assemble the robot later on, will help your team do the prototype, and manufacture all of the parts that you need. In this episode, we're just going to show you a basic tutorial of Fusion 360, the CAD program that we're going to use in this series. And in the next one, we're going to show you how to sketch your whole robot and get all of the numbers you would need. So now let's move on to the tutorial. Okay, so now let's get going with the tutorial part. So for anything that you would want to CAD out, you want to first create a sketch. A sketch should be a 2D version of whatever you want to do. So let's start by creating a sketch. So use this tool right here, create sketch. And for that, you would need to choose a plane to draw your whatever shape on. So right now, let's choose this plane right here, which is the front plane. When you're sketching, you have three basic types of functions. First is the create. Basically, you create different shapes, different things that basically this is bread and butter of whatever sketching you need to do. You can add lines, the most basic shape. This is like its name, just a line between 2 points. The first click is going to decide where the line starts. Second click where it ends, and when you continue on, it will continue on from the end point of the previous line. Your next click is going to be the end point of your next line. If you want to exit this function, you can double click. You can click a point that you already have on your sketch, or you can press escape. Okay, so let's delete those. Other functions you have are creating rectangles. These are the different types that you can use. The most simple one is 2-point rectangle, which is where you create a rectangle out of the 2 corners. The limitation of this one is mostly it will line up with the 2 axes. You cannot make a rectangle that is going this way. You just can't do that. It's not a thing that you can do with the 2-point rectangle. If you want to do that, you would need to use a 3-point rectangle, which is where you choose 3 different corners. Let's delete those and move on to the next one. The next tool is going to be a circle. The first click is going to be the center. The next click is going to be one of the border. So basically, just draw the radius of the whole thing, and we'll create your circle. You have other ways to draw a circle, but that's the most simple way, and most likely you just use that one and add on constraints later to limit it or set it somewhere you want. You can create an arc, you can create polygon, clips. Everything is very simple and bare bones. You read the name and you basically get it. The things that most likely you won't get are going to be the spline and the dimension. So let's talk about those. But first, let's just delete this so we have a clear. A spline is basically a smooth curve that goes through all of the points that you choose. Right here, it goes through all of those black points, and then when you want to modify it, you can modify these these green lines and green points here called the spline handle. Basically, if it's longer, it will follow the spline handle more closely, and if it's shorter, it will just doesn't follow at all. You can modify those. This tool is very useful for when you're making weird shapes, when you only have some constraints of the whole shape, but you don't really know what the shape is like. For example, if I want
a smooth curve that goes through some points, draw out a random shape. Let's say this is a rock and I want a smooth curve that just covers the whole rock. I can just choose all of these, and well, I need to change the spline handler later on, but well, yeah, basically you can get a smooth thing that covers the whole thing. It's very useful when you just have some constraints but you don't know the whole shape. Okay, so that's it for the spline. Really, for now, you don't really need to know much about the spline. It is not something that you would need to care about when you're just starting out. Let's just delete off those and get to the next thing. The next function that you might be confused about is the dimension. Dimension is basically adding size and constraints that are related to numbers about everything that you have here. Let's add some shapes, and now let's test the dimension function. The first thing that you can change by using the dimension function is the size of everything. You choose a line, you can choose the length. You can change the length of the line. Let's say right now is 107 millimeter. I can change it to 50. You can see that it's shortened by more than half. You can change the angle between two lines by pressing both of them. Right now it's 52. I can just type in 80 and it will turn into 80. You can change the length of it in a certain axis. So this is the length of it in x-axis. I can change that to 40, for example. I can change the diameter of a circle. Furthermore, I can change the distance between the center of circles and just generally between points. Let's put this as 200, for example. Another thing that I would like to note about using dimension is that there's a thing called driven dimension. So, for example, if I choose this thing here, instead of clicking it immediately, I change this to driven. You can now this will not change the actual length of this line, but the number will change accordingly when you change the length of this line. Basically, if you have a part that you don't know what's the size of it is, you can just add a driven dimension there and change every other thing, and then whatever you're left with is the number you need. Okay, then you can move on to the modified functions and the constraint functions. Constraint is basically adding relations to different objects that you have on your sketch. You can make two lines be parallel, make their length equal, make them perpendicular to each other. Basically, these things are very easy to understand. It's just relations between different lines, different circles, line and circles of the objects. It's very simple. Fillet is creating a round corner between your lines, and trimming, like its name, you just cut things out. Offset is, well, you make an offset of whatever you want. Like this here is basically it's copying this whole shape, pushing it in a perpendicular to whatever point it's copying. The offset function, basically it offset whatever you want. Yay! As its name, basically it push whatever every single point in the thing that you're trying to offset in a direction that is perpendicular to the slope in that particular point. So everything in this line over here will be pushed in a direction that's perpendicular to the line. This curve right here is going to be pushed inward toward the center. That's why this curve is very small compared to this one. That's basically the jig for offsetting. Okay, because I know that this will not help much by just talking about the tools, we will now try and make an actual thing. And in making an actual thing, I will show you things that are there from the sketch. And by making an actual thing, I will show you functions that are there from a sketching function. Let's start that now. Okay, so we're here in a new file to create an actual object for this tutorial. So when I learned how to CAD, I was taught how to make a die. When I teach anyone to CAD, I teach them how to make a die. So that's going to be the same thing. We're going to make a die. So first, like every single CAD file, you would need to start with a sketch. So a sketch of a die is of course going to be a square because the die is going to be a cube. So you center rectangle, start from the center of the whole file and stretch out. The first thing you would want to do is make these two equal because you want a square and not a stupid dumb rectangle. Then add in the dimension for a side to adjust the adjust the side of the die. So 50 I think is good enough. After you have a 2D sketch, you then have to use one of these two functions to make it into a solid. Because it's going to be cube, you want to push it up. So that's the extrude function. So that's just creating a solid object by pushing your sketch in a particular axis. But because we want the center to still be in the center of the whole sketch to still be in the middle, don't want to push it only on one side. We want to push it on both sides and for it to be symmetrical. So both sides should be 25 for the total length of it to be 50. So add in 25. Okay. So now you have this cube over here. The thing about a cube is that if you have the whole thing right here, it looks a bit silly. You never see a die that is a perfect cube because that just looks silly. So one of the things that you can do is use this function over here. Basically, this function is going to smooth all of the edges. Let's take, for example, let's smooth down these three edges. If I add a 5, it's going to smooth down so that this cut right here, the radius of it is, the diameter of it is going, the radius of it is going to be 5. We want to smooth out all of the edges. So remove the selection and we're going to select the whole thing. And 5 seems good, so yeah. This immediately looks better, but we can still do a bit more. So let's just delete the further function. This way to make a die look better is kind of like a trade secret for me. So first you would need to draw a thing that's right in the middle. So let's choose a plane that's in the middle to draw a circle, and then just take out a big area around that. So the thing you want for this is for the corner right here to be very small. So 64. This now is 64. The corner still seems a bit too big. Let's add it up. Let's just add some more to it. Let's say 67. Well, yeah, that looks good. Okay, so because you don't want to cut out, you just don't want to like extrude cut the whole thing out, because if you extrude cut a cylinder out of here, you're just going to be left with like these 4 awkward corners. You want to use a revolve cut. This function is basically just spinning an area around an axis after choosing to do whatever, either add a new body or cut things out. So right now we want to choose this big area around here, use one of the axis right here, and change it to cut instead of new body. Yeah. We just cut that out, and this looks pretty nice. It's kind of a mix between a cube and a sphere. It's kind of weird, but it looks good, so I guess that's why I like it. So for die, you would want to draw out the holes. So for those of you who can't really remember an orientation of the holes in die, just remember that the two opposite sides will add up to 7. If this side is 6, this one is 6, this one is going to be 1, this is 2, this one is going to be 5, if this is 3, that one is going to be 4. So let's start. We can make the hole in a myriad of ways. So first way is to just draw a circle and do the thing similar to what we did to create this nice shape for the dot. Just revolve cut it around. If you just make the center of the circle to be straight in the middle, that would look really weird as the hole is way too small but way too deep. So you just want to offset it a bit up. Generally, what I found to look pretty nice is if you were to make the distance between the center of the circle and a face to be 1/3 of the diameter of the circle. So if I put this as 9, then the distance from here to here should be 3. Yeah, so this small area over here is going to be the cross section of the thing that you're going to cut out. So again, use the revolve cut function, choose this area over here, and choose this axis to cut out the whole thing. Also, you cannot choose areas on both sides of the axis because that will cause errors in the system. Only choose areas on one side of the axis. Cut that out and we have this nice hole up here. Let's continue with other ones. So the next one I want to draw is going to be the 3 hole, because that's another simple one because it has a hole right in the middle. So again, draw a circle, draw some lines to separate it in 2 halves, so that, and also to be the axis for your revolve cut. If you, again, because this one is going to be the 3 and not the 1, should be a bit smaller. That is 9. The one previous was 9, so let's just put this as 6. This is 1/3 of it, so it's going to be 2. And then we can cut it out. Again, revolve cut, choose this one, choose the axis, cut. Okay, we have a smaller hole over here. Now, because we don't want to draw 2 circles over here, we need to make an extra plane. We need to do a lot of stuff, and that would take a lot of time. We don't want to do that because everyone is lazy and everyone should do things as efficiently as possible. We're just not going to draw new circles and cut new holes. We're going to use a pattern. So basically to use a pattern, you copy whatever body or feature as the thing that we're about to do. We're going to copy the revolve cut feature right here and copy it in a particular direction. For the 3, we're going to copy it diagonally. So we need a reference for it to go diagonally. Let's draw that reference right now. So first, draw a line, and then just, actually we need to draw 2 lines. This is trying to act stupid, so let's make this constant. Let's just add another line. That's more simple. Okay, so dimension, make the angle between these two be 5. So that's going to be our reference. Now finish this sketch and move on to this thing. So the pattern type is not going to be faces because the thing that we're copying is a revolved cut, which is a feature. So copy this feature. The direction that we're going to copy it along is this axis. It's a 3, so we need to cut it on both sides. So symmetrical. Let's check. Now let's just change the numbers and see what looks nice. Okay, 15. You can see the 2 holes over here. That's good enough. Okay. If you want it to look better, you can hide your sketch. Where is it? Yeah, here it is. You can hide it. So now we can move on to the 2 hole. So basically the 2 hole is just the 2 holes on the side of the 3. So we can just copy this and move it to another face. Okay, so we're not going to use a rectangular pattern because we can only, that one doesn't change, that one just push it up somewhere, and we cannot just push it down way to this way because we also need to spin it so that it's on this face instead of this one. So what we're going to use is the circular pattern. That again, what we're copying is a feature, particularly the rectangular pattern, and the axis that we're spinning along is the y-axis. We don't want it to go a full circle, we just want it to go 90 degrees, and we just want to copy. As you can see, we cut 2 holes over here. If you want, you can make a separate one so that the 2 holes are closer to each other, but for this example of a die right here, I think this one is fine. So the next one we're going to make is going to be number 4, which is going to be on this side because 3 and 4 add up to 7. So the 4 hole doesn't have any hole in the middle, so we can't do what we did for the other one. We need to make an extra plane because we want to draw it so the hole is over here. We need to draw it on the face, on a surface that is a bit up from the surface that we have right here that goes straight through the middle. So what we can do is this function, offset plane. It creates a plane that is a particular distance between that is a particular distance away from what you choose. So for now we want it to be a bit up from this one, so it's going to be a bit up from the x and y plane. So x and y. The distance between the hole is going to be 15. So that's the distance from the middle is going to be 7.5. Yeah, so we have this surface right here. Let's choose that one and create a sketch on it. So it's going to be on this side up here. Again, the procedure for creating hole is the same thing. Add some dimension, 6. Okay, so again, revolve cut to cut out the hole that we need. Now we need to copy it, so we have 4 holes. Again, what we're going to use is the rectangular pattern. Copy the feature and not the body itself. Let's take for example, if we choose the body, click in the hole, we're just going to copy this whole big die, and we don't want that to happen. So feature, direction. We want it to be along this and this axis, so Z and Y. Yeah, it's that for me already. So let's change. Let's take 15. Okay, we can see that it pushed up here, so we want it to go the other way. So let's add minus 15. This one over here should also be 15. Okay, we can clearly see that I messed up and did not put this in the place that it's supposed to be. Let me change that a bit. So just roll back to the sketch. You can edit it by choosing edit sketch right here. We want it to be 7.5 on the center because it's half of 15. Okay, finish. Yeah, okay. If you feel like this looks a bit too close to each other and too clump up, another thing that you can choose to do is instead to make the distance between the diagonal to be like tiny or something bigger, or just change up the number a bit. But for now, this would work. So another simple one to do is going to be the 5, because the 5 is just the 4 with something in the middle. So again, like what we did with the 2 and 3, we can copy these two functions and do a circular pattern to get it to this face that is opposite of the 2. Axis, you can see here and the top that we want to spin it around this axis, so that's why we just want to go 90 degrees. Just want one copy, so okay, and yeah, we copy those over. We can probably copy the middle hole from the 3 to be over that way also. So again, we can take, so it was this feature. Use the circular pattern and copy it up there. So it's again going to be the y-axis that we're going to spin it. Yeah, we're going to use the y-axis. Okay, so 90 is the other way around. So let's just minus 90, one copy only. Finally, we have the 6, and that is going to be basically the same thing with what we did for the 4. Offset a plane, this time just offset it with this plane here, the XY plane. I'm just going to speed through this because you've seen plenty of times where I draw these things. So 6 and 2. So because we don't want it to just push this way and we want it to also push the other way, so let's again choose symmetrical. We want this to be 15. The other one, we just want one copy, and it should be 15 also. Yeah, okay, those look nice. Okay, so that's it. Now we have a die. That's the basic of CADing. By making this die, you learn how to use extrude, evolve, how to sketch things out, how to use the pattern, and how to construct planes and other stuff. That's mostly the basic things that you would need to CAD to just start out with your CADing journey. That's it for this tutorial.
So that's it for the CAD tutorial. In this episode, you've learned some basic tools and some basic tips about Fusion 360. And that's all I have for this tutorial. In the next episode, we're going to show you how to sketch out your whole robot and get all the numbers you would need to do manufacturing, to prototype, and basically everything you would need for your robot. Thanks for watching and listening. See you in the next episode.